4.7, inverse trig functions. The first inverse trig function that we're going to talk about is inverse sine. And if you remember, when we find an inverse, like if I wanted to find the inverse of y equals 2x plus 3, I would swap my x and y and solve for y. And so if f of x equals 2x plus 3, then f inverse of x is x minus 3 over 2. And you also remember that if this one had a domain negative infinity, positive infinity, range, negative infinity, positive infinity, that your inverse function, its domain is the range of the original, and its range is the domain of the original. So that's what we did with, other functions. Now we're going to do the same thing, basically, with the sine function. So if we had the sine function, y equals the sine of x, and we wanted to find its inverse, we're going to turn the x to a y, turn the y to an x, solve for y. Since this means that y is the angle when x is the ratio, then we say that y is the inverse sine of x. And the best way for me to remember it is you're always taking the sine of an angle and you get a ratio. But if you're taking the inverse sine, it is the ratio and your answer is an angle. I think that is the best way to remember that. Okay, so they start by showing you the sine function. So this one is y equals the sine of x. And you can see that it goes positively through 0, 0, and it's at its highest point at pi over 2. Its lowest point is at negative pi over 2. And what we have to do is we have to restrict the domain of that sine function so that we can even find an inverse. Because I don't know if you remember, but if you have, a function like the sine function, to find an inverse, it has to be, of course, a function, but it also has to be a one-to-one function. If it's not one-to-one, you can't find the inverse. So how we go about that is we say, well, and I don't know if you remember, but for something to be one-to-one, it has to pass the horizontal line test. So that means it can only go through the function one time. The horizontal line can only go through the function one time. If it goes through more than one time, it's not one-to-one. So this function is not one-to-one. So I'll put on there, not. Okay, this function, y equals the sine of x, is not one-to-one. The only way we can find an inverse is if we restrict the domain. So what they do is they decide, I'm going to take the function from here to here, and I'm going to throw out everything else. And do you see how at that point you only have here to here, and it passes the horizontal line test? So that's why you can only look at it from negative pi over 2 to positive pi over 2 when you're looking at the inverse function. So this one on this side is the inverse sign. So the unique angle y in the interval negative pi over 2 to positive pi over 2, such that sine y equals x is the inverse sine of x, denoted inverse sine, or sometimes we call it arc sine. The domain of y equals the inverse sine of x is negative 1, 1. The range, negative pi over 2, positive pi over 2. So normally, if you had y equals sine of x, the domain was negative infinity, positive infinity. The range was negative 1, 1. But we took y equals the sine of x, and we said we're only going to look at the domain negative pi over 2 to positive pi over 2. Our range is still negative 1 to 1. So we restricted that domain, and that allowed us to have the inverse, which the domain became negative 1, 1, because our range became our domain, and our range became negative pi over 2, positive pi over 2. So that became that. Okay, so let's look at example number 1. Evaluate inverse sine without a calculator. So the first one we're going to look at is the inverse sine of negative 1/2. So when we're looking at it on the xy axis, think about where negative pi over 2 and positive pi over 2 are, okay? So if I went in the positive direction, if I was thinking, okay, I'm going to go, at a positive, there's my pi over 2. If I go in the negative direction or clockwise direction, there's my negative pi over 2. So these are the only two quadrants that you're going to find an inverse sine in. So if inverse sine is positive, you're going to go to the first quadrant. If inverse sine is negative, you're going to go to the fourth quadrant, because all of your answers are going to lie either from 0 to pi over 2, if it was a positive, and I'm talking about if this ratio is positive, you're going to go to the first quadrant. If that ratio is negative, you're going to go to the fourth quadrant. And again, if your answer is negative, or if your ratio is negative, your answer will end up being somewhere between that 0 and negative pi over 2. All right, so now I'm going to get a different color. Okay, so I see inverse sine of negative 1/2. So I'm going to the fourth quadrant, and I'm going to draw my triangle, and I'm thinking about what is the angle such that the opposite over the hypotenuse is -1/2. And then I think, oh, well, this is my 30, 60, 90, with this angle right here being 30 degrees. But it's actually coming from the positive x-axis down in the clockwise direction, and we know that 30 degrees is the same thing as pi/6, and clockwise is -pi/6. So the answer to that part A would be -pi/6. And the reason why we had to stay in the first or fourth quadrants is because we have that restricted domain that we started from that gave us the restricted range in the inverse function. Okay? All right, the second one, part B, inverse sine of square root of 3/2. And I want you to remember that if you take the sine of an angle, the answer is a ratio. If you take the inverse sine, you're taking it of a ratio, and your answer is an angle. Okay, so we said that up top, but this is exactly what we're doing again. Oops. All right, so now let's do this one. The first thing you do, draw your XY axis. You know that you're either going to be in the first quadrant for positive ratio or the fourth quadrant for negative ratio. Okay, you're either going to be between 0 and pi/2 as an answer, or you're going to be between 0 and -pi/2. Okay, so basically you're either going to find your answer here in that region or here in that region. Okay, so since this is positive, I'm going to the first quadrant, and I'm looking for the angle such that the opposite over the hypotenuse is square root of 3/2. And I hope you realize that I'm saying opposite over hypotenuse because this is inverse sine. And so this would be 1. This is going to be 60 degrees, or pi/3, and that's positive. So our answer here is pi/3. And we might want to write along with this that we wrote right here, we also might want to write for inverse sine. If the ratio is positive, your triangle is in the first quadrant. If the ratio is negative, your triangle is in the fourth quadrant. Okay, so that basically tells you exactly what to do when you're solving an inverse sine. All right. Next one. This is an example of inverse sine of the sine of pi over 5. So on these types of problems, you have to start here. Start with this one, and we're going to figure this one out, and then we're going to take the inverse sine of that answer. Okay? So we're basically taking the inverse sine of whatever this one has as an answer. All right. Here we go. So first thing we got to find is the sine of pi over 5. So if I draw an xy axis, here's my sine of pi over 5, or pi over 5 is here, and some angle, and it's going to be some x, and I'm going to make this an r, just because, I don't know, when you draw a triangle, I always think about, like, if that were a circle, and this would be the radius of the circle. That's why I call it r, but that doesn't matter here, but we're just going to use two letters, okay? Opposite over hypotenuse. And so if you think about this, and that you are then going to find the inverse sine of this, because we don't really know what x over r is. But if we were going to find the inverse sine of it, wouldn't the inverse sine, because remember, the inverse sine, our answer is going to be an angle. So we're taking this as a ratio, and we've just decided that that ratio was x over r. We already drew it, though. It's right here in the first quadrant where pi over 5 is. And so the answer to the inverse sine is going to be pi over 5. So you can imagine that sometimes, not all the time, but the inverse sine and the sine kind of cancel each other out when they're in the first quadrant. If they're not in the first quadrant, it doesn't always work that way. So let's do one that doesn't work that way. The inverse sine of the sine of 3 pi over 4. So this time, we're going to draw our xy axis. And we have to go to 3 pi over 4. And 3, oops, moved on me. Three pi over 4 is all the way over here. So there's my 3 pi over 4, so I know this is going to be pi over 4. So this is 1, negative 1, square root of 2. And the sine, opposite over hypotenuse, is 1 over the square root of 2. So this is going to become inverse sine of 1 over the square root of 2. Because I basically just took this answer and put it in right there. So now I'm finding the inverse sine of 1 over the square root of 2. So now I need to go according to inverse sine. If this is positive, I go to the first quadrant. So that means I go and draw my triangle right here in the first quadrant, and I'm looking for the angle such that the opposite over the hypotenuse is 1 over the square root of 2. And so my answer is going to be positive pi over 4. So your answer always is going to be either in the first quadrant or the fourth quadrant. It has to lie. This answer has to be in the interval negative pi over 2 to positive pi over 2, because that is the range of your sine function. All right, now we're going to go to inverse sine or inverse cosine. Inverse cosine has the same problem that inverse sine had. It was not a one-to-one function. So we had to restrict the domain of y equals cosine. Only the restricted domain that we ended up using was from 0 to pi. Okay, so when we were looking at the sine function, the cosine function, and we said, oh, does it pass the horizontal line test? No, it doesn't. So that means it's not one-to-one. And you're like, well, can't find an inverse, except if we decide to take it and restrict the domain. So we restricted it, and we're only going to look at it from 0 to pi. Okay? And then we're able to find an inverse. So this is that piece of my y equals the cosine of x. And then this is what it looks like when we look at y equals inverse cosine. And so the unique angle y in the interval 0 to pi, such that cosine of y equals x is the inverse cosine or arc cosine of x, denoted either the inverse cosine like that or arc cosine of x. The domain of y equals the inverse cosine of x is negative 1, 1, and the range is 0 pi. And for this inverse cosine function, let's write that if you're finding the cosine of an angle, you get a ratio. But if you're finding the inverse cosine, it would be of a ratio, and your answer is an angle. And if we had y equals the cosine of x, our domain was negative infinity to positive infinity. Our range was negative 1 to positive 1. When we took it and we restricted it so that we could find an inverse, our domain became 0 to pi, and our range negative 1 to 1. But then when we found our inverse, our range became our domain, and our domain became our range. And so for inverse cosine, if the ratio is positive, draw your triangle in the first quadrant. If the ratio is negative, draw your triangle in the second quadrant. Because your range from 0 to pi starts here and ends there. It's going to go from here to here. Positive inverse cosine, negative inverse cosine. All of your answers will lie between 0 and pi. Okay? So it's different than inverse sine. All right. And then inverse tangent. For the tangent function, I don't know if you remember what tangent looks like, but since tangent x is the sine of x over the cosine of x, wherever the cosine is 0, there's a vertical asymptote. And so it just keeps going like that. All those vertical asymptotes at pi over 2, 3 pi over 2, dot, dot, dot. And then your tangent function keeps going like that. So you could see that if I tried to draw to see whether it was 1 to 1, it's not going to be 1 to 1 unless we restrict the domain. So again, not 1 to 1. So we restrict the domain. So we're just going to focus on that one. We're not gonna do any of the others. Okay, so we're gonna focus from negative pi over 2 to positive pi over 2. Only non-inclusive because they have a vertical asymptote there. So if you look here, it says restrict the domain to get your inverse tangent. So this one is your y equals the tangent of x. This one is y equals inverse tangent of x. So we have the unique angle in the interval and negative pi over 2 to positive pi over 2, such that tangent y equals x is the inverse tangent or arctangent of x, denoted this and this. Remember, it's not tangent to the negative 1. You can't drop it down as, you know, and move it like it's a different one. It's inverse tangent. The domain of y equals inverse tangent is negative infinity to positive infinity. The range, negative pi over 2 to positive pi over 2. non-inclusive. And you can kind of see that if we had y equals the tangent of x, goodness, our domain was, x is an element of the real numbers such that x does not equal any 2n plus 1 pi over 2, because all the odd pi over 2's, it can't be, right? You can't have an odd pi over 2. And that does say the real numbers. And this line right here means such that. So every single x value is in the domain of tangent except all the odd pi over 2's. And this would be where, the way I wrote it is where n is any integer. And so that means if n was 1, that would be 3 pi over 2. If n was 0, that'd be 1 pi over 2. If n were negative 1, that would be negative pi over 2. So it can't be any of those values. And when we restricted it, oh, and the range was negative infinity to positive infinity. When we restricted it, we said, okay, we can't have that domain anymore. We had to make it just negative pi over 2 to positive pi over 2. We still had the range of negative infinity to positive infinity. And then when it became the inverse and we swapped it, our domain became negative pi over 2 to positive pi over 2, and our range became, our domain became negative infinity to positive infinity. Sorry. Our range became negative pi over 2 to positive pi over 2. I think I said that wrong. I always get ahead of myself. So for this one, for inverse tangent, when you're looking at, the ratio, because it's going to give you a ratio, because it's going to say, like inverse tangent of 1 or something like that. It's going to, this is going to be your ratio on the inverse tangent. So if the ratio is positive, draw your triangle in the first quadrant. If the ratio is negative, draw your triangle in the fourth quadrant. Okay, so that's for inverse tangents, first and fourth. The only thing that's different about the inverse tangent is, it still goes from negative pi over 2 to positive pi over 2. You just can't have an answer that's on, it's going to go from here to here or from here to here. But it will not have an answer that's on the y-axis. where the sine function could. Okay? So what I'm saying there is that if you had like a problem, what is the inverse sine of 1? And you say, okay, here we go. It's positive. I'm going to go to the first quadrant. But then you quickly realize that if you put 1 over 1 here, that doesn't work. So hopefully you would think, wait a minute, on the unit circle, this right here, this point right here is the point 0, 1 cosine sine. It's at pi over 2. Oh, my answer is pi over 2 because that's the angle where the sine is 1. So sometimes you're on the unit circle on the axes, but you still can only have an answer. That answer has to lie between negative pi over 2 and positive pi over 2. Okay? So if I said, what is the inverse sine of negative 1? And you're like, oh, hopefully you figured out that you can't draw a triangle in the fourth quadrant such that the opposite over the hypotenuse equals negative 1. And then you realize, wait, on the unit circle, this is the point 0, negative 1 cosine sine. You would not say 3 pi over 2 because that's not in the interval. So you would say that the inverse sine of negative 1 is negative pi over 2. That would be your answer. Okay? We wouldn't call it 3 pi over 2 because this answer must be in this interval. Okay? So it's not that it's technically, it's a technicality that it's wrong. I know you know that that's also 3 pi over 2. But what we say for inverse is it has to lie between those two values. So you have to either talk about it between 0 and pi over 2 if it's positive, or between 0 and negative pi over 2 if it's negative. But for inverse tangent, you're never going to have the answer of pi over 2 or negative pi over 2 because it's not included in your range. See how that is not a bracket. So if I said, what is the inverse tangent of 0? You'd be like, well, that's positive, I guess. No, it's not really positive. Am I in the first quadrant? Am I in the fourth quadrant? No, you're actually on the axes. So you would draw the unit circle and you'd say, this is the point 1, 0, cosine sine. I know that my tangent is sine over cosine. So sine over cosine. This would be 0. So if you're looking for the tangent of 0, that would be sine over cosine. Tangent of 0 is 0 over 1. It's 0. So where would my tangent be 0? At 0. So that would be your answer. So it would be on the axes. You really wouldn't have another one for inverse tangent on the axes. You will for inverse cosine though. Okay, so let's finish this off. So now, composing trig and inverse trig functions, the following equations are always true. When they are defined. So, here we go. The sine of the inverse sine of x is always going to be x. The cosine of the inverse cosine of x is always going to be x. And the tangent of the inverse tangent of x is going to be x. The following equations are only true for x values in the restricted domains of sine, cosine, and tangent. the inverse sine of sine x is x. The inverse cosine of cosine x is x. The inverse tangent of tangent x is x. And like I said, only if x is in the negative pi over 2, positive pi over 2 region. And again, if x is in that 0 to pi, if x is in that negative pi over 2 to positive pi over 2. And notice the difference. This one, you're taking the sine of the inverse sine. That one's always true. This one, only true for the restricted domains. So see how this is different? The inverse sine is on the outside of this one. So if inverse sine is on the outside, you have to be careful. If it's sine on the outside and inverse sine on the inside, it's a pretty easy problem. Okay? So you'll be seeing that as